heard about it. And also, are you like RCC users? I think I'm familiar with a couple of you, but I haven't. I don't know whether you are RCC users or not. So I'm just trying to get some background before we move forward. Jupyter Notebook is okay. So first of all, I'm using Jupyter Notebook to like talk about Jupyter Notebooks here, so that you can get some experience of like what can you do with it. So what is Jupyter Notebook? I'm sure most of you have heard about it. So it's a way to run a code in a web browser, but not just that. You can add visualizations like text, graphs, or like any like tables, references, anything. So it's you can embed code in it. I mean, it's the main purpose is sort of using like running code, but you can embed text and other items to explain what you are doing. So it's good for like, I mean, if you use it with Git, you can have like version control and all that complexity built in so that you have like a very maintained code base. So basically, you can use it to like document your work. Like if you're doing research, right, you can like, keep track of what are you doing, why are you doing, what are the results, and how it changed over time. You can like self-document your research as well as you can share it. It's mostly popular with Python, um, but you can use Jupyter notebooks with R, Julia, and many other coding languages. Just to like give you an idea of what it is, if you don't know about it. So these are just few examples, like the LIGO experiment. For example, they share their work as like Jupyter notebooks. So this is, so you can see it as a like web page, right? That's another like handy use of Jupyter, because you can convert your Jupyter notebook to a HTML page and like embed it in a blog or other website. So this is you can see it's an HTML file, but you can download it locally. The IPython notebook. Oh yeah. Yes. So you can download, because I'm running this on HPC, so I can. There are some limitations, but if you open this in like your local machine, you can download this and run it locally and change, make changes to it and rerun it. Like for example, you can change the analysis. You have to download all the data of this particular notebook, but you can change the analysis. I mean, you can see what they've done here, and you can see what happens. So that this is like reproducible research. When you read a paper, it's just they're just talking about it, but when you get the actual workflow, then you can make changes and you can verify their results, or you can use it to conduct your own research. So that's why I said it's like it's enabling reproducible research. Also, so you can install Jupyter locally in your computer with as usual, like pip install Jupyter. Also, if you are I'm sure most of you are, if you are an RCC user, it's very easy to use Jupyter with Open on Demand. You log into this website. the ood.rcc.fsu. Okay, so I blew up the font size because I'm doing presentation. Okay, so this is the website, and if you go to interactive apps, Jupyter Notebook, so you end up with this page, and you can specify like which Python you want, like Python 2 or Python 3. I'll come up to this box in a minute, and the usual things: the partition, number of hours, say if I want backfill, say 4 hours, one node. So for most of the analysis, you think you just need one node, but Jupyter can use more than one node with, like, for example, IPy parallel, so things like that. Then you might want to change this number and specify number of cores and how much memory. You can keep everything default if you just want to do something basic. And before you run Jupyter for the first time, you have to do this. Like, you have to, like, Python is installed like on the our system, like PC systems, but you have to install Jupyter yourself. But it's not really hard. We give out the instructions here in our documentation. So it's here. So it's just 3 lines of code. You can just copy paste. You get a shell. So you click. Sorry about our regular users. I'm sure you are familiar with this. So I'm just showing this for anyone who's not familiar with doing this. So you load the Python module. Say 513, and so it's installing Python envelope. I just gave this location, the test directory. So it's installing Python there, the Python 3 virtual environment. And now I'm all set. And I just need to install Jupyter. Right? So this is only like one-time thing. So test, then install Jupyter. And after it's done, you are ready to run the Jupyter Notebook. So you give that location. For example, my home directory is GPFS home Prasad. I made this like ahead of time. I have, and my newly created one is a test. So test/bin. Don't forget to put the /bin at the end. Okay? So then when you launch it, yeah. So my test environment is ready. Now I can get rid of this terminal thing. This. Okay, so I have one running here. That's my talk. And this is my new, um, oh, no, yeah. So this is still waiting. Okay, so now it's ready. Okay, so you end up with something like, I mean, this is my home directory. So you will end up, you will see different set of directories, for example. So if you are new and you will not have any notebook, so you can create a new notebook with here, code here, and you need Python 3. So that's your new notebook. So any questions so far, like how to like install or how to connect to OOD, like Open on Demand, and run Jupyter Notebook? Okay. So how to use Jupyter Notebook? So like I showed you before, you just need to select a kernel or a language and open a new notebook. The default mode is for writing code. Like this called a cell. This cell is, you can put a Python command like the import pandas/pd, and that's a code, right? And if you hit enter, not there, but nothing will happen. It's just going to the next line. So to run this, you have several options. So you will see the toolbar. I just hit the toolbar just because to save some screen space. So few options. You can do this with run, or you can hit Control Enter to run this cell, or Shift Enter to run this cell and add a new one below. Like for example, if I do this, so it's running, and a star indicates that this command is still running, and you will get a new cell to, you know, the next command. And also you can do Control Enter, and it will just run and will not add anything below. And if you do Shift Enter, it's the same thing as hitting the run command. So now if you want to put a comment, like we call it markdown, if you want to convert this to like a text field, um, so you can either like hit escape, and you can see the cursor disappeared, and then type key M, then now this is no longer a code cell, now it's a markdown or text cell. So if you hit Shift Enter, it will not be just text. It's not, it's not code. So Jupyter Notebook understands this as text. So it will not give you a syntax error or anything. So escape and M keys would be, the other way to convert a cell to markdown is simply going here and select markdown. Right? That's the easiest way. You have code and markdown. So I can. So if you want to edit a markdown, you have to double click on it and then select, say, heading. And if you shift enter, now it's a heading. Not just a text, it's a heading. Likewise, the escape plus Y or selecting code would convert it to a code cell. So you can interrupt running a kernel or restart at any time. So I showed you when the import is running, there's a star here, and if you want to stop that command from running, you can either go here and interrupt the kernel, or go here and do one of these. You can interrupt, restart, clear output, likewise, or shut down. Also, I'll skip this one for now. The notebook name is by default untitled. Yeah. So the name is untitled. So when you click on it, you can change the name. And it'll automatically save it, but it's a good idea to go ahead and save while you work on it. Also, so you can see this, if you go here, it's IPyNB, so IPython notebook. And you can save this as HTML or Python code or anything you want. So if you go File, Download As, you can see there's HTML, LaTeX, Markdown. Of course, the default is notebook and PDF. So you can select any of the formats and export it and share it with someone, or move it to a different machine and run it, or whichever you choose to do. Okay. So these are some basic ideas. I'll let you read it, but so you can clear the outputs, or one or all outputs, and autocomplete. So there are some important things such as the exclamation mark and the percentage sign. The exclamation mark is used to run like shell commands. For example, if you're a Linux user and you don't want to go here and get a shell and run a command, right? So you can do it on the notebook. For example, if you want to install a Python module, you can just do exclamation mark or bang pip3 install matplotlib, for example, and in this case, it's already installed. So now also you can see the hourglass when the command is still running. So you can interrupt it if you want and for any reason. So exclamation mark or bang is used to run shell commands. The percentage sign is also a special character. We'll come to that later, but those are called magic commands. There are some magic commands built into Jupyter, which are very handy. So I'm not going to talk about Python right now, because by default it's Python, but I'm not going to teach you Python. I'm assuming that basics of Python. So I'm not going to run advanced Python code here. So for example, if I do say 1 plus 2, then the output will be 3, and the handy or nice feature of IPython notebook is Jupyter notebook. Okay, since I said IPython notebooks, for some history, it used to be IPython notebook, but now it's all Jupyter. Technically there's no IPython notebook, so it's called Jupyter now, Jupyter. So Jupyter notebook, the nice feature is that you can see the output of each line. You can stop it from showing the output, but the default behavior is to show the output in every cell. Like if you want to mask the output, you can put a semicolon and it will not show you anything, right? But by default, it will show you what the output is. So there are some handy things you can do. For example, the underscore always refers to the previous output. So, for example, underscore plus 3 would be 6 in this case because the previous output is 3, right? These are some handy features. Also, you can access you have the out array, you can call any of the outputs and do operations with it. Also, you can recall the inputs, the commands that you entered before. So you can see the order, I ran this notebook before, so that's why there's 4, 3, 4, 6. But I ran this right now. If I run it again, it will be 5, 6, 5. Oh yeah. So now this can be 1, this can be 5. So yeah. And anything Python will run here. Example, it's a for loop. So the next nice thing is the graphs. And before that, I have to talk about these magic commands. So you can see I put a magic command here. It's called matplotlib inline. So the default behavior of Python is not to show the graphs embedded in the Jupyter notebook. But but we want everything nicely embedded in the notebook like this, right? So for that, you have to enter this command. It's called the magic command, matplotlib inline. There are few magic commands. I'll come to that later, but this is the first one you'll be seeing. So you can see it's so all the graphs are very nicely embedded in the notebook. So I just ran. Okay. Also, feel free to ask me if you have any questions related to this, or if you have if you are using Jupyter Notebook and you have questions, just feel free to ask me anytime.
Hey, Prasad, we had a question about TensorFlow.
Sure.
If you have multiple versions of TensorFlow, do you have to use different, or if you want to use multiple different versions of TensorFlow, do you have to use different environments, like one environment per version of TensorFlow?
That's a very good question. I think the question is referring to virtual environments, right?
Yes.
Okay, so the short answer is yes. You can keep things very clean by that way. For example, I'm using TensorFlow for some stuff, and I have at least 2 virtual environments, if not more. There's one with MPI, one with CUDA, and I think one older TensorFlow that I compiled for HPC. So yes, and when you submit a job, So when you submit a job, the Open on Demand will automatically fill this field. So you have to be careful that you select the right environment for the job you are running. So the answer is yes. Yeah, so you see that I have at least 3 virtual environments, but this is virtual environment 3. So creating tables. So I'm talking more about like Markdown. Let me back up a little bit. I want to show you like the Markdown. So this is my this is the notebook I created for this talk. And if I double click on it, you can see the code, the Markdown. So it's not too complicated or anything, right? So for the heading, you can I hide it. So you can go here and figure out, which mod you want to use, like which type of heading you want to choose and all that. You don't have to remember anything. Or you can do escape and the number. Escape 1 is the heading level 1, escape 2 is the heading level 2, and so on. And okay, I have a list here, so you can see. That's the reason I created these slides in a notebook, so that I can show you the slide, and then I can show you how the Markdown works. If I double click on it, so the header and the list is basically I put a dash and a space, and make sure that you put a empty line in between the items, and that's it. So that's the formatting. Also, I have few links. That's the reason I put links, because I want to show you how to put a link. So you put the text in a square bracket and don't put a space, and the URL should be put in the parentheses. So it is really simple. It is not too many things to remember. And you can, if you type the link, it will still be clickable, but you will see the link. But if you do this, it will hide the actual URL. It will only show the clickable text. And you can do multiple levels of lists like this. So you just put a tab here and dash and a space, and if you do 2 tabs, that's the next level. And it will control the bullet automatically, the type of bullet. One thing, so somebody asked me about TensorFlow. So there are a lot of notebooks that you can data. If you are data science oriented, then you can get a lot of workbooks from examples from Kaggle. Okay, so there are 400,000 public notebooks, for example. So you can get any of these notebooks and try them, combine them for your analysis. I mean, that's what I end up doing sometimes, because if I see something that's useful for what I'm doing, then I just copy it and then change it. So these are code, so there's nothing to. And the other thing is creating tables. This is nicely formatted, but with minimal effort, right? So you just put lines between the fields, and this is the only non-intuitive, so to speak, part. But okay, so these control the whether they are justified, unjustified, aligned, or not. That. So for example, this field, the first field is unjustified, and second field is center aligned. So the only downside is there's no spell check, so you're on your own. I'm sure somebody developed an application for that, but I haven't found anything that spell checks your notebooks. I'm sure there's like in the GitHub somebody did that. Yeah. So then you just insert your fields, and then the markdown will nicely format it, and you get the table. And also later you can convert this whole thing into LaTeX if you are a LaTeX person, and then you can copy the table into your paper or thesis or document, whichever you choose to. And you can convert these graphs into the whole thing into EPS, and then the graph you can save the graph into PostScript for submission or anything. It's same as Python. Inserting images. This is just an image from our website. So inserting images is really simple. Yeah. So you can. The easiest way is to go edit, insert image. Right. That's the easiest way. I mean, this is a little bit. Too much to remember, but it's just like a URL link. So I talked about magic commands earlier. So there are there are several magic commands. Like for example, matplotlib inline, just we saw it, and the time it. There are two type of magic commands: magic, like cell magic and line magic. So with 1% sign, these are called line magic, and the 2% signs are like cell magic. So if you do LSMagic, it'll list all the magic commands. So these are available line magics, these are available cell magic. So most of these are self-explanatory if you are a Linux user, and if you are not, you don't need all of these. For example, if you need the LS, okay. So one thing I forgot to mention is how to insert cell. You can insert cell above, below, relative to where you are. So you can see if you do. There's two ways to do this, but yeah. So these are all the files in this current directory. Okay? So you can also do this with the bang ls, because that's a shell command. So the output is the same. Most of these you can do with Linux commands, but it's handy to have magic commands. The most important ones are history. This is the history relative to the current kernel. If you restart the kernel, the history will be deleted. So you can see all the commands that you entered during this session, right? This is not this session. I was running this few times before, so you can see the history. So that's an important magic command. Also, time it. I think most of you, if you are a Python user, then you must be familiar with time it. So there's time it line magic and the cell magic. The one thing you have to remember is that the magic command has to be on the like if it's a line magic, then it's simple. But if it's a cell magic, it has to be at the top of the cell. Otherwise, it's not going to work. So I'm just comparing the two commands, like sum command and like manually adding numbers. So I'm just timing those. Any questions so far?
Yeah, we have two quick questions.
Yep.
One was, are you going to post the this notebook that you're using on the RCC website afterwards?
Yes, I can. I mean, that's the purpose of creating this. So yes.
Okay, cool. And also, is it possible to submit a non-interactive job to the HPC cluster using Jupyter? We got a question from somebody that says that they might have if they have a very big data set that needs to be processed in Jupyter, can you submit a job like a multiple node or multiple core job to the HPC using Jupyter?
Okay. The idea of using Jupyter is, interactive access. Interactively see, what's going on and how it's working out. Yes, you can submit a Jupyter job with Jupyter, but the thing is, you have to be like I'm just thinking while answering. So one option is to use a small set of the big large data set and verify that your Jupyter notebook is working, and then convert it to a Python code, like code download as .py, and then run your entire data set with it. The main idea of using Jupyter is interactively running and messing with data and see how it's working out. So Open on Demand can so if you want to submit a regular job, you can use Job Composer, and I'm sure you're familiar with how to submit a job, right? So if you have like a large data set, I think that's the best option. But is there any specific reason that you want to use Jupyter for that? I mean, you can run it and then come back in a while and see the output. But other than that, no, Jupyter is mainly for interactively working on your data or the code. Did that answer the question? So I'm going to I'm going to give a small data science application, show you data science application, just because Jupyter Notebooks is very famous or very very much used with data scientists these days. So this is a small example that we are working on HPC. So we are working on some tweets and related to COVID-19. And like I said, you can put headers or comments, different levels of headers, so that when you look at it, you know what you did. and read the data. And when I was answering the question earlier, so this is what I mentioned, this is what I meant by saying that Jupyter is mainly for interactively dealing with data, because you read the data file. This is not like a big data file, so it's like few megabytes. So you can see the header of the file. You can do the same thing with Python in terminal, but you will not end up with a log of all the commands you entered. Plus, you will for sure not be able to save all the outputs. But like if I close this, notebook right now and open it later, it'll still have the output. So that's the main advantage of running Python on the terminal versus the Jupyter Notebook. But the downside is, it's interactive. Right? But the best way to deal with that is, you verify your workflow on Jupyter, and then convert the Jupyter notebook into Python code, and then run it as a non-interactive job. So you can look at your data and see how many rows, how many columns, and what the data looks like. And then you can see, especially for data science, then you probably have to remove the note number, like nans and infinities and all these fields. So for that kind of thing, it's very handy, and then you can get a feel of data. I'm not going to explain what you're doing, but just get a feel of data and see what each column has, and then the main idea is you just get the data file and look at it and see what you can do with it. If there are any surprises in it, and then how to deal with those and train it. So in data science, that's something very important. Like you spend most of the time training the data and creating a workflow, right? So for that, I think Jupyter Notebook is the perfect uh, method, one of the perfect idea. I think I showed you. Okay, so I created a link to a file here. So it's easy, right? It's just like a URL. So my example notebook is also on the same directory, so I can just say // and the notebook name. And it's like a URL. I can hide the actual file name and just display the clickable text. So I don't think I have any graphs here. Yeah. Yeah, the other thing is, we are dealing with tweets. So there are characters. If I looked at these in example terminal, this would be just a ASCII number, but in Jupyter they will be converted into actual characters, so I can understand the data better. Right? Yeah. So that's just a small example of how to use Jupyter in data science. So one thing I want to show is briefly using something other than R, so something other than Python for Jupyter Notebook. for example, R is very popular, right? I'm not a R user, so I don't have much experience, but I just tested this. So if you are using Anaconda, it's much easier to do this. So there are like few commands that you have to run. So conda install R essentials, and then you have to create the R environment with conda, and that's all you have to do. And without Anaconda, you can still you can still do this either on your local machine or on HPC, for example. I've tested it on HPC, so you can do the same thing. If you have like a virtual environment, um, for Python or Jupyter, and then you can install locally the IR kernel package or the module, the library, I think, in R language. And these are libraries in R. So IR kernel library, and then the install spec. So those two commands will create the R kernel for Jupyter. And then when you go here, it will show you the R kernel. I can show an example here. Um, uh, uh, so this is my local installation. So you can see there's R. So this is now not Python. This is R. So you can see it's R language here. Example, this one of the few things I know how to do in R. So it's R. I mean, so you can. I haven't tested, but I think Julia is much like Python. So Julia works with Jupyter, and R works. So if you are used to R Studio, you don't have to do this. You can just use the Open on Demand Jupyter. Sorry, the R Studio. But if you are used to, I mean, you can use this. If you are used to Jupyter and you want to like convert your research into like HTML or something, and you want to use that ability, then it's real easy to not this. It's real easy to do your like work in a Jupyter notebook based on R and convert it into HTML or share it with your colleagues or whichever, or you can publish it as a web page. So if I save this as an HTML, then I can incorporate it with my blog or Git or whichever. So that's what I want to talk about today. So if you have any questions, I think it's the time. Also, if you have like, so one thing I didn't talk about is, yeah. So how to use Jupyter with more than one node. So you have to do a couple of things. You have to like increase the number of nodes here. That's easy. And the problem is that's not a Jupyter Notebook talk. That will be like IPy parallel or something like that, depending on the package you choose. You have to do a few things, but those are like not very advanced. I mean, you can either Google it or we can help you. You know, if you really want to do that, we can help you if you send us an email with support at RCC. If you send us an email, we can help you with that. Those are like very specific applications. That's the reason I didn't want to like talk about that in a Jupyter Notebook, talk. But if that's something you want to like learn more about it, let us know. If there's like enough interest, we can like give a short workshop on that topic alone, because there's enough to talk about, that. So any questions on Jupyter, or like anything I talk about here, or anything you want to know? It's the time.
I have a question. So, what's the advantage of Jupyter over the Python GUI?
Oh, that's a good question. So one thing is you can save the workflow, the inputs and the outputs, and also you can, you can document what you are doing. Like, for example, if you look at something like this, right? So this is more than just this is all in a notebook. This is more than just something you type in the Python GUI, right? You can put notes and everything. So that's the main advantage.
Mm-hmm.
And also you can save it, and somebody else can run it and, change it, that's the big advantage.
Okay, so my understanding is more like the advantage based on the interaction. It's like interactive.
Yes.
Okay.
Yeah. Mm-hmm. And also, you can save it for yourself. When you're doing research, most of the time, like when you're doing it, it's very clear to you and you don't need an explanation, right? But mm-hmm. you come back to it in a few months and you're like, what exactly am I doing, right? Mm-hmm. So that like documenting like this saves you a lot of time, because if you document in a code, you are very like limited with you can't put any graphs or like sketches or anything. Mm-hmm. But here, you can easily draw something in a notepad and then attach it here, right? Mm-hmm. So yeah, those are the main like advantages.
Thank you.
So if you have any more questions, either you can ask now or let us know here. Let us know at our website and the email address. Alex?
Don't see anything else in the chat.
I think we answered most of the questions, right? You answered most of the questions, so thank you.
No problem.
Okay, then thank you all for attending this workshop, and we will post this notebook on the. I think we have a section of our website dedicated for that. So we'll post it there, and you can have a look. Okay, so thank you, everybody.